So hey guys, my name is Greg. I'm a senior backend engineer with Vacuumlabs. And fun fact, I'm actually not a JavaScript engineer, but I think cross-cutting concerns are like security is relevant for all the platforms. So what I have to offer you today is a pragmatic look at authentication in microservices. And I just lost my slides. It's going well. So I thought we could start with the basics. You probably know most of this stuff, so I'll make it quick. So what is authentication anyway? So let's say I want to look at a painting, a real painting. I mean, it's probably a replica, so not the original, but the real 3D image, object. That's not what computers are concerning themselves with, unless you're into smart locks or alarm systems. So we need kind of digital representations. So I would need an identity. Actually, I could have several. So I could have my personal Gmail account, my corporate Gmail account. And the painting would need to have a computer representation, a JPEG image, a file on a computer, a resource on a server, a blob in a database. And authentication is about asserting my identity based on my credentials. And authorization is about making security decisions, whether I'm allowed to do certain things with the resource, so whether I'm allowed to view the image. And actually, there's two kinds of authorizations, or two categories. One is roles-based authorization. So let's say I'm an admin of a system, which means I could look at all the images. So role-based authorization is much simpler. It doesn't look at the individual objects. You could probably do this at an API gateway at a very high level. It's just about deciding whether I have a role to do something with anything. And attribute-based authorization is looking at the attributes of the resource. So for instance, if you are actually the owner of the image. And it gets a bit trickier here because, for instance, performance is a leaky abstraction. So it could be that you would need to solve your security decision by including it in your SQL query to only select rows from the database where you are actually the owner of a file. You would not want to return all the images and then filter them out in an API gateway, for instance. So I'll get back to these concepts later, so that's why I just wanted to get these out of the way. So how does all this work in a traditional monolith? It's the good old days when things were simple. You had just a single server. So you had a front end with a login screen, and you logged into the back end, and you could just really put everything together. So you could store your username and passwords, hopefully not in clear text, in the database. The user could log in. You could create them a session. You could put things in the session. And as the user, for instance, is shopping in an online store, you could use this session of the user once they logged in to run your things, like put maybe the shopping cart in a session. The user adds things to the shopping cart, and then when they check out, you can like ship the goods to the user. So that's the simplest like monolithic way to handle security. But as you get into distributed systems, it can get complicated. So let's say you read about microservices and you want to extract delivery into its own service. So how would this work? Now you could try to do things the old way. You could probably make them work. So you could still have a session in your main backend service. And this is a special case because delivery is something that doesn't depend on, like the user doesn't access delivery directly. Like the shop, only your shop component could talk to delivery. So you could kind of make it work. But as you may need to scale up your shopping service and you had multiple instances of the same service, things again start to break down a bit more. So where do you keep your session? You cannot just keep it in memory like you before, but you could have put it in a database or like some shared network cache. Again, it would come with some restrictions. You couldn't put anything in the session store, but you could probably make it work if you wanted to scale out just a single service. But if you break out yet another component, which would be accessed by a user directly, actually it could be accessed by your delivery component and your front end. Again, things would keep getting more and more complicated. So it could make sense to extract your authentication logic into its own service. And in this example, your front end would first log in with this service. It would get a cookie. So you could keep a cookie around and just try to keep sending the cookie down to your other services. It could get complicated if your cookies are tied to like URLs or domain names. You might have to jump through some hoops to make it work. But you could still make it work. However, you can see as it's getting like incrementally more complicated as you distribute things incrementally more into separate services. So there is a standard. Actually, it's a set of standards, OAuth 2. There was OAuth 1 briefly, and then they made some breaking changes. So whenever you refer to OAuth, it's usually OAuth 2. And it kind of defines an architecture and gives you some predefined ways how to do authentication. And it basically defines 5 actors to the system. So it's me again, and the picture I want to look at. So those are the same. And then this is how you would over-engineer it in a distributed system. But it comes with some benefits. So I'm the resource owner. And the picture is my resource. And this distinction becomes interesting when, for instance, this is Facebook. So it's still my image, even if it's hosted on Facebook. So I'm the resource owner, and I use a client to access my resource, which is hosted on a server. So the client could be a mobile app, it could be a browser, or it could be a command line tool, or it could be another service. So the client is not necessarily tied to a user. It's just a generic way how you define the components of making this all work together. So these are the dependencies. So I use the client to both access the auth server and the resource server. The resource server hosts my resource. And the resource server trusts the authentication server, which knows me. So there's like this transitive trust. That's how the resource server knows me, that it trusts the auth server who knows me. So that's the dependencies. And this is how the login flow and getting access to my picture actually works out over time. So I use my client to first send my credentials to the auth server, my username and password. And it's now exchanged to a token. As an example, I'm using a JIT token. I will get into that in a minute. So instead of a simple session ID or sessions, the best practice to use in this architecture is to use a token. So the auth server returns the token to the client, and then the client keeps sending this token to the resource server to make the requests, and that's how the resource servers would know I'm authenticated. Now, how does the resource server know that the token is valid? There's actually a couple of ways to do this. One is the resource server could always ask the auth server, like, is this token valid? The other way to do it is the token could actually be cryptographically signed with a private key here. The resource server will need to know the public key. And there is actually an OpenID configuration standard with which you can get automatically. And the good news is there are actually existing libraries and frameworks which takes much of this off your shoulders. So in one of the projects we did, we just included a library. There was like one configuration needed in the file to define the URL of the auth server. Everything was configured in the resource server. Most of the complexity went in the client for the login form and the auth server, which wasn't implemented by us. And the resource server basically just had to look at a token, see if it's actually valid, and could decide whether to serve the image or not. Just scroll again a little bit. So getting back to our original web shop example, how would this change things, or how would this help? So like I mentioned, that instead of a session ID or sessions, we would use the token here. So you would still need to enter username and password. It goes now to the authentication service, which could be a third party, by the way. So there's many third-party providers. Like there are companies doing this full time, or there is like Amazon has its solution. If you're running in the cloud, you could just, with a few clicks, set it up in for instance, AWS. So this could be a third party. And now you can only focus on your business logic. So you get the token, you send it to all the backends. Like I mentioned, they can validate it. And you don't need to use tokens. So one thing to note here is that if this backend component communicates with that backend component, You could just say that, yeah, I trust that system, I wrote it, so I know what it does, but try telling that to Russian hackers. So it could be a good idea to include some security even between your own services. And that actually could be like you could use a token for that. You could use a token which wouldn't be the user token anymore. It's still the same token format, but you could actually issue a token to your backend service, which is not tied to any user, secure your communication that way. Or you could actually use TLS, and by this I don't mean just simple HTTPS, but client-side credentials. So you could configure, like it's pretty common in like Kubernetes environments to set up end-to-end certificates and even have the calling side have a certificate to assert its identity. So in addition to the tokens, even between your services, you could also use security provided by, for instance, TLS certificates. And you could take it even a step further and introduce some boundaries around your system. You could have an API gateway which knows about tokens, and then internally you could just rely on TLS from there. And you could set up a firewall, so a firewall around your whole system, or even like in AWS it's called a VPC, so like these subnetworks with, again, firewalls rule defined. So you could take this whole thing to the next level in addition to using OAuth. And this is called security in depth, or like layered security. So once you arrive at an architecture like this, where you have multiple ways to authenticate and multiple layers of security, if someone breaks through, like maybe they hack your gateway or hack one of your shady backend systems, the rest of your infrastructure is still protected. So I don't have the time now to get into the details of OAuth in all the nitty-gritty, but I would recommend to familiarize yourself with it because it's a widespread standard, a set of standards. So you might have come across it already. And it's really powerful and gives you a lot of help how to solve security in a distributed system. So I mentioned I would talk a little bit also about tokens. So a token, a bearer token, is something that whoever has the token has all the credentials. So it doesn't directly, a bearer token doesn't directly identify the user. So when they log in to the auth server and they get the token, that token, in the case of a bearer token, doesn't directly identify the user. But whoever has this token has all the credentials that the user has. So this is a very simplistic use case, but it's also really powerful. Like, it reduces all the dependencies. Like I mentioned, that a backend service, as long as it can say whether the token is valid, it doesn't have to look at or doesn't depend on what other properties the user has. And technically, a JSON web token is also a bearer token in the sense that whoever has the token has full access. But a JSON web token is actually, it's a base 64 encoded data package. Let me scroll again. And the way it works is, if you decode it, it actually has 3 sections. One is just a header that says this is a JWT token and it's encrypted with SHA-256 algorithm. The middle part is the interesting part, is the payload. So you can actually ship some data in your token down to your services. And the JIT standard actually defines some standard fields, like the subject is who the token is for, issue that's IAT, so a timestamp when the token was issued. There could be an expiry date, there could be a number of other standard fields, or you could even add your own fields into the token. So you could ship down to your backend services things like the user's name, or roles, or like application data. And then the final part of the JIT token is a cryptographic signature of the 2 previous sections. So it's not encrypted, but it's signed. So you can decode it, you can read the contents, but if you change anything above, it would mess with the security signature, and you could like detect that it's been messed with. There's also support for encrypting your token if you want to be really security conscious, but most of the cases, just signing your token is enough. And like I mentioned, if this service knows the public key of the authentication server who issues the token, they are the only ones able to issue the token with the private key. That's how you have this distributed trust set up. And that's basically what I had to say in kind of 50 minutes about authentication in microservices. Thank you. If there are any questions, happy to answer them.